Okay, so in section 3.3, we're going to look at some properties of logarithms. All of the properties of logarithms can be based on the properties of exponents. So we've already studied the graphs of exponential functions and logarithmic functions. You guys already know how to simplify or manipulate exponential expressions using properties of exponents. So now we're going to look at manipulating logarithmic expressions using 7 properties of logarithms. So remember, I told you guys I'm expecting you to already know your properties of exponents. Come talk to me if you need any help with those. Okay, so a lot of these just go back to the definition of a logarithmic function. So let's think about rewriting these first 3 in their exponential form. So like the log base b of 1 equals to 0, well, b to the 0th power is equal to 1. You know that's true, right? Any real number except for 0, which the base cannot be 0, raised to the 0th power will be equal to 1. So this first property basically says if you take the log base anything of 1, you'll get 0. The second property, right, we can rewrite as b to the 1st power is equal to b. Well, that's true. B equals to b. So that says that if you take the log base b and evaluate it at the same number as the base, you'll get 1. Okay. And then the third property, b to the x power equals b to the x. So that property tells us that if we have the log base b of a number raised to an exponent and the base of the exponential function matches the base of the logarithm, then that's just equal to the exponent. Okay, this is one of the inverse properties. So to show that this is a true statement, let's think about rewriting this in its logarithmic form, right? Like, let's think about this being an exponential form where log base b of x is just the exponent. Okay, so in logarithmic form, we would do the log base b, right, because of the base here, of x is equal to the exponent, and the exponent in this case is the log base b of x. Okay, so if this base matches this base, it's just equal. This simplifies to be just the argument of the logarithm that's in the exponent position. All right, product rule. You're going to need to memorize product rule, but I'll prove to you that the left-hand side equals to the right-hand side here. So basically, if you're taking the log base b of a product, you can rewrite that logarithm as a sum of 2 logarithms, which the input of each of those logarithms would just be the factors of the product, okay? So b raised to this power, so b to the log base b of m plus the log base b of n is equal to the product m times n. So now using properties of exponents, I can prove to you here that the left-hand side equals to the right-hand side. So all I've done so far is rewrite in the equivalent in the equivalent exponential form. So exponent properties, I can rewrite the left-hand side here as b to the log base b of m times b to the log base b of n. Right? Right now I'm proving that the left-hand side equals to the right-hand side. Well, the property above Okay, so property number 4 tells us that that's equal to m, and this, again by the property above, would be equal to n. So we show that m times n equals m times n. Yay. Okay, but really you need to memorize that property. Similar thought process in the proof, that the left-hand side equals the right-hand side for the quotient rule. B raised to this power, so b to the log base b of m minus the log base b of n equals to the quotient m over n. Okay. Exponent properties. I can rewrite the left-hand side here as the log, as b to the log base b of m over b to the log base b of n, right? Because you can, if you have a quotient with the same base, you can subtract the exponents. So kind of going in the reverse. Okay, and then property 4 again. This becomes m, this becomes n. Yay. Okay, so quotient rule, product rule, you really just need to remember those. Alright, number 7 is my favorite logarithmic property. In class we talked about why this is. But basically the log base b of m raised to the p power is equal to p times, so that exponent, p, times the log base b of m. So I call this property plog. Right, we plug and we unplug. But it's known as the power rule. Mr. Romanoff just likes to call it the power rule, but me and Miss Walters call this plug. So b to the p times log base b of m is equal to m to the p power. And I'm going to prove that to you. Okay. So I'm going to rewrite this, again, exponent properties, as b to the log base b of m raised to the p power. Okay. Well, inside here, again, by that property number 4, that's just m. So we get m to the p equals m to the p. Yay. Okay, so again, call this plug. We plug, or we unplug. I call it a plug when you pull the power down, and then I unplug when I move the p back up into the exponent position. All right, these are the same properties that we've just talked about, but with log base 10 and natural log. Okay, so let's use our logarithmic properties to simplify. Log base 5 of 5 will be 1, right? 5 to the first power will be equal to 5. Okay, log base anything of 1 will be 0, right? Because that base raised to the 0th power will give you 1. 10 to the log of 2 plus x. Remember, when the base is not written, it's log base 10. So this just equals 2 plus x. Okay, I believe that was property number 4. Yes, property number 4. We use property number 4 a lot. Okay, for D, e to the ln. Okay, so same base here and here. So this will be equal to 3x minus 4, again by property number 4. Okay, so the log base 10 of 10 equals to x squared. So because these bases are the same, okay, that's equal to x squared. You could also think about it from a plug perspective. So if we have the log of 10 to the x squared and we plug it, we would pull the x squared down front. So it would be x squared times the log of 10, and then log of 10 is just 1, so that would give us x squared. Okay, and this will just end up being x plus 5. Okay, same base, right? Ln is log base e of e to the x plus 5 power, so that'll just be equal to x plus 5. Okay, so we are practicing simplifying or rewriting logarithmic expressions because we're going to be using these skills when we are solving exponential and logarithmic equations in the next section. So let's use logarithmic properties to rewrite the expression as a sum of simpler logarithms. So we can use the product rule here. Just a reminder, I'll scroll back up to it. Product rule. Okay, so I can rewrite this as a sum of logarithms, so log base b of x to the 4th plus the log base b of the cube root of y. And then I can plug each of these logs. So I can pull the 4 down front. And then cube root is the same as raising y to the 1/3 power. So I can log and pull 1/3 out front. And now we have a sum of simpler logarithms. Okay, so let's rewrite the sum of two logarithms. As a single logarithm. So first let's unplug each of those logarithms. So I'll have ln of x squared. In class they asked me about when to write the parentheses around the argument. I usually write the parentheses around the argument. Do that, you'll see when we start studying trig as well, just to keep the argument separate so there's no question of what the argument is. Okay, so now we can use product rule. Rewrite this as our single logarithm. So ln of x squared times y cubed. And we're done. Okay, so we'll rewrite this expression as a difference of logarithms. So quotient rule, log of a to the 4th, so log of the numerator minus log of the denominator. And then we could even plug each of those logarithms. So 4 times the log of a minus 5 times the log of b. Alright, let's rewrite this expression as a simple logarithm. Notice that all of these have a base of b. So that's the reason that we're going to be able to rewrite this as a single logarithm, a simple single logarithm. Okay, so first we need to unplug this guy and this guy. So we'll have log base b of x cubed plus the log base b of 2x plus 1 minus log base b of 4 squared. Okay, we can use product rule to rewrite that sum as a single logarithm. So the log base b of x cubed times 2x plus 1. I'm going to write that as minus the log of base b of 16. So then we can rewrite that difference as a single logarithm using the quotient rule. So log base b, I'll distribute the x cubed in, so it'll be 2x to the 4th plus x cubed all over 16. And we can leave that like like so. Okay, so we are going to expand this logarithmic expression. So first what calls out to me is quotient rule. So I can rewrite this as a difference of the log of the numerator and the log of the denominator. Notice that there's no base written, so that means log base 10. We can only do this, well, I guess we only started with one logarithm, so they didn't need to match. Okay, and we can actually go further because we can rewrite each of these arguments as products. So we'll have the log factor of x minus 2 times x plus 1 minus the log of x plus 4x minus 1. So now I can split up this first logarithm using product rule. So log of x minus 2 plus the log of x plus 1. And you need to be careful. So I'm going to do minus the sum of logarithms. So log of x plus 4 plus the log of x minus 1. And then distribute that negative. And we're done. Alright, change of base formula is used in different derivations that you guys will see next year in calculus, but it's also it's another way to evaluate logarithms. And you'll have the option of evaluating logarithms or sometimes in solving equations to use apply change of base formula. But basically what change of base formula says is that the log base b of m is equal to the log base anything. Okay, these bases need to match, but they can be any real number that a base is allowed to be. So basically between 0 and 1 or greater than 1. They just need to match, but they can be any number. So the log base a of m over the log base a of b. So for example, if you wanted to evaluate the log base 7 of 10, okay, that's equal to like the log base, I don't know, let's say 2 of 10 over the log base 2 of 7, which is also equal to, which this makes it easier for typing into your calculator. You don't have to then go to the math menu and then scroll up. You could do just the log of 10, because there's a log button, over the log of 7. Or you could do natural log of 10 over natural log of 7. All of these are equal to each other. All of these, when you type them into your calculator, and you can double check it yourself, we would get approximately 1.183. Okay, so kind of cool. Usually, if you're using change of base to evaluate a logarithm, it makes sense to use log base 10 or log base e, just because there's buttons on the calculator to do that. Okay, so if we did log base 7 again. Okay, so like if we wanted to evaluate log base 7 of 34 using change of base, we could just do the log of 34 over the log of 7. And then you can type that into your calculator. and we get approximately 1.812. You could have also, like I said, you could have also done like ln of 34 over ln of 7, and you'd get the same thing. Okay, so that's it for section 3.3. Next, we're going to be using these properties and properties of exponents to help us with solving equations.